Hello everyone, welcome to Java Sessions. Okay, I know it has been a while since our last video. If I remember correctly, it was Java loops, Java for loops, and while loops, how they work. You should check it out. It was an awesome video. So since then I have taken a gap since I made another video, but here we are. We're back. So in today's tutorial video, we will be focusing into Java data types, primitive data types to be exact. By the way, Java has two types of data types, which is non-primitive data type and primitive data type. Non-primitive data types are like arrays and your strings. By the way, strings are my favorite data types. But then strings will be discussed on another video. Today, let's talk about primitive data types. Do we have eight primitive data types, or at least that I know of are eight. Those are char, boolean, byte, short, int, long, float, and double. But for today, we will be focusing on primitive data type that are used to hold integer values, which are byte, short, int, and long. Okay, so let me explain them a little bit further. A byte is an 8-bit signed integer, and then a short is a 16-bit signed integer, and int is a 32-bit signed integer, and a long is a 64-bit signed integer. Okay, for now let's get into the question. By the way, I've already read this paper, so I won't need to get into the question. You can just pause the video, go through the question yourself. And also, I will leave this link in the description below. Let me click it. It just talks about primitive data types, not just the one that contain integer values. It talks about, for example, here is float, double, boolean. Those don't contain integer values, but they are also primitive data types. Okay, now let's get into the question. By the way, the input we're going to have a t, which is the number of test cases, and then we're going to have n, which will be an arbitrarily large or small value. Okay, this is how our output will be. For example, we'll insert 150, negative 150, 150, and then it will check that's negative 150 in the range of negative 128 and 127. Nope, hence one byte cannot contain 150. Moves on. Short, definitely short can contain 150. By the way, if it can't be contained in a long, then it can't be contained anywhere. So that will help us in our try catch block. Yeah, let me go through the paper so you can pause and go through everything. If you didn't understand, this is how our output should be after we're done with this video. Okay, okay, so what I'm going to do now is instantiate t, which is the number of test cases. Let me comment here. See, see that next. I honestly didn't know what to comment here say. So actually let me just give space. The next int. Okay, here let's say t is the number of test cases. Okay. Oh wait, first let's prompt the user so that doesn't become that dull. Print, you just say print, and number of test cases, perfection, enter number of test cases. Okay, now we already got the number of test cases from the user. So what do we do next is go through the loop. Int I is equals to 0, I is less than t, and then I is perfection. Oh, by the way, if you're not familiar with for loops, I have made a video about for loops. Actually, for loops, well, generally what loops in Java. which is just for loops and while loops. But then you can just go check out that video, and yeah, I won't get deeper into an explanation in this one, and I'm just showing you the ranges between the primitive data types that hold integer values. So what you're going to do next is going to need a case. So we're going to need n. So let's ask the user here, system out print enter. Actually, I'm going to need a try catch block. Remember what I said earlier? I said that if a value can be contained within a long, then it can be contained anywhere. So let's say try catch. Let's say try catch finally. Okay, perfection. Awesome. Here we're going to just let's see dot close. Remember, it's always important to close the scanner, whether you're using a data input stream, or whatever it is that you're using to get the inputs from the user or from the machine. Always close it afterwards. We'll dive deeper into try catch block exception handling when we are starting to do file and writing into files, moving from files. That will be upcoming in my next videos, probably like 2 or 1 week from now, most likely 4 days from now. So okay, like I said, now we need system. Let's ask the user, hey, please enter the case that you wish to test. And the case, let's see long. We'll make it long and it's possible. Let's see the next. Okay, and then here I haven't done anything with exception. That's weird. Let's see that next. Down here, let's see, can be fitted. Remember, if it's not a long, then it's not anything. So it can't be fitted if this strike fails. And now we move into the interesting stuff, the if statement. By the way, if statement, I've already made a video which is also including if else statement. The actual 2 videos, which is part 1 and part 2, if else statements. So do check it out if you want to know more about if statements. Right now I'm just going to write it down. I'm not going to explain how and why it works. So let's roll. So now let's check the byte first. Remember, the byte ranges from -128 to 127. So if you find out that n is greater or equal to -128 and n is less or equal to 127, then what do we have? Should I just do? Oh yeah. And then what do we have? Oh, I forgot something. System print line the same and plus can be fitted in. So yeah, n can be fitted in byte. We don't know. It will depend according to the user's input. So let's see system system dot print line so it can be fitted within a byte. that's okay. Now I'm not not to say I'm being lazy or anything, but I'm not going to repeat the same syntax. We're basically using the same thing here, so we're just going to use the same if statement for checking if it can be fitted within a short. So the short ranges from negative 32,768. Let me write it down here. Negative 32,768, and then its maximum value is 32,767. 2,767. Oh yeah, that's it. And then if it isn't within that range, then it can definitely be fitted within a short. And then yeah, let's get our next. And if it and int ranges from, that number is really huge. So instead of actually calculating the power, I'm just going to say write the whole number. I'm just going to say method power. This is a function that comes with Java that just say negative 2 to the power 31. That's it. You just calculated negative 2 to the power 31, which is the minimum value an int can be fitted in. And also, yeah, we'll do the same thing here, but instead of negative 2, no, don't do that. But instead of negative 2, we're going to just say 2. Perfection. Then it falls on the int, not short. What am I doing? And then we do the same thing for long. I said ing, int, not ing. Long 63. Perfection. Okay, so I think like I said, this in this tutorial video, the syntax wasn't that much of concern. Look at how simple it is. Our concern really here was just showing you guys the wide ranges, our data value, our integer holding primitive data types, which ranges they work with. And let's say maybe you're going to work with a number that is somewhere around 32, 35, 20 something thousand. You definitely can instantiate it as pi. So they're just trying to show you that, to know how to use our primitive data types, especially the ones that are holding integer values. Know which one is appropriate. Know when you like, maybe int is too small for this one, so maybe you're going to use long. Long is the max. If it can't be fitted within a long, it can be fitted anywhere. Hence, can't be fitted. Okay, let's test this code. I believe it should work now. It should work. Enter number of test cases. Let's say 5. Enter the test case. Let's go to that question. Negative 150. Negative 150. So negative 150 can be fitted in a short, int, and long. Is that true? Well, a short, you can just switch here. Yeah, it's within that range. And then is it within the, yeah, it is. And long, yeah, that's true. So it works for negative 150. Let's check another one. 150,000. 550. 1, 2, 3. Yeah, it's definitely anything but a short. Yeah, a short is definitely way below 150,000. So let's go to our next case, which is I believe this one won't fall under int, just a guess. Oh, this number is so huge. I'm just going to copy and paste. So I'm just going to copy and paste. Let's see number is. Oh, that's fall under int. Let's check something here. Oh yeah. Just for another int. Let's enter our last case. Actually, no, this is not the last case. Yeah, this number is huge. Okay, yes, it can't be fitted. Like, where would you fit this? No way. No way you can fit this number. There's just no way you can fit this number. It can. If it's not long, then it's not anything. Let's go to our next value. This one, I have suspicion that maybe, just maybe, it might not work, but we'll see. Like I said, just a long. It works only on long, not an int, just long. Okay, interesting. And now let's check our answers. We're going to use here sample output -150 short int long. Our -150 short int long, perfection. 150,000 int long, int long, and then int long. Is it here? It is int long, and then this number can't be fitted anywhere. What about here? Perfection. And then this one is just long. What about here? Perfection. Okay, ladies and gentlemen, that's how primitive data types works. The ones that are holding integer values. That's how you know maybe when you're building an app, you know you're going to deal with values that are greater than 128 or greater than maybe 32,000. Then just know for a fact that you can use short or you can use byte. If you're going to deal with values that are larger than that, then I would suggest most of the time int works, but if just to be safe, use long. I suggest only that you use long just to be on the safe side, because if long fails, then there's nothing you can do. But then if int fails, then you can use long. Hence, I would suggest in your application you use long. Okay, ladies and gentlemen, we are done. Thank you for watching. Please subscribe, leave a like, and stay tuned for more amazing Java content.